does that have to go to notes since it goes from page to page?
No, it's used as a local note, not really a general note. Okay, the general notes in the bottom right-hand corner applies to the drawing as a whole. You can use it there, but I probably wouldn't. I would use UOS in its place. Say all these are this unless otherwise specified. And so anything that's undimensioned on there is going to get that. Yes, Pat?
So would it in the notes, wouldn't it also be typical like fillets and radiuses, a diameter or whatever?
Mm-hmm.
It could go in the notes.
It could go in the general notes and
Okay.
apply to the drawing as a whole. And I wouldn't use typical with that.
You just say fillets.
Those are meant, typical and the 4-bys are meant for local notes or notes that apply directly to a feature, as opposed to a general note which applies to the drawing as a whole and is sitting in the bottom right-hand corner. Do you understand the difference between the two? Yes.
Can there be more than one typical on a drawing? Or do you just want
I'd be
to?
real careful about that.
Okay.
Yes, there can be, but your geometry should be way different.
Okay.
Don't do it on a hole that's a 1/4 inch and then do it on another one that's 3/16. Too typical, right? Because who sees that? A lot of mechanics would, but they do it every day, right? They reach in, you always wonder how those guys reach into a toolbox or look at one thing in an engine, walk half a mile to a toolbox and pull the right wrench out. Experience, right? Most people can't do that. Are your questions answered on that? Does everybody understand the difference between a local note and a general note?
Mm-hmm.
Nice question. Kind of went on a little rabbit trail, but I think we clarified some stuff. After that, we went to tolerancing. Again, we had some terms, definitions. I'm not going to get carried away with tolerancing on this, per se, but every drawing needs to be toleranced, right? Every drawing. You can do it through a general note. We can do it by direct methods, or applying it to the dimension in its whole. Know the two types. What are our two methods? Bilateral and
Limit.
I'm talking about direct tolerance. There is one is bilateral, where I give the basic size and the deviation from that basic size.
Limit dimension.
Yeah, limit dimensioning, where I give the limits of the tolerance. Know what the definitions are. Tolerance, definition of it. Basic size. Allowance. Maximum material condition. Least material condition. I'm just spitting them off, but they are listed in your text on page 845. We spent some time on fits. If I use fits on the test, I will copy a fit table out of the machiner's handbook for you. I will get those worksheets you turned in yesterday graded and back to you today to see if you make sure you understand that you read the text correct. So if you understand how to read a fit table, whether you're a clearance fit, transitional, or interference, you'll be good to go. We don't have enough machine's handbooks for everybody, so I will copy any information that we use out of there and attach it to the test. In essence, I think that's the review. Are there any specific questions that I didn't cover that you have questions on, or?
What was the name of that address? I didn't understand. Is there anything we need to know?
Those are thread forms?
Red forms?
Yes, and they are part of the English and metric thread.
Red forms.
Yeah.
What was the question?
The thread forms on page 9, chapter 19, that first couple pages, what was it, page 911?
913.
913.
Okay.
I'm going to stick with unified national or metric. The two that are generally,
Okay, okay.
yeah, you aren't going, I'm not going to throw
That's
a thread we haven't dealt with.
Okay, it's all
Cheryl.
humans.
English was on page 913 and metric was on page 917.
But the thread form is part of the thread note, right?
Mm-hmm.
I mean, if you got a diameter 3/4 -UN, that's it, unified national. Or if you got a diameter M, that's a metric, right? So you're calling out thread form on those.
Okay. I just didn't see the Acme anyway. Samples.
Any other questions? All right, I did say I would kind of go over this guy real quick. Gabe, would you mind hitting the front lights, please?
Oh,
And I just wanted to give you an idea how to put this together and save you a little bit of time.
yeah.
Not that you really need it, but
Just nudging you.
I give myself a little room here. Here's my key, not that, as you know, as you dimension things, there's a lot of different ways to do stuff, right? So yours might not match up with mine exactly, but in essence, you're gonna have your block part here, you've got your pin, and what you're doing as far as dimensioning. Now, we're really trying to control the operation of this thing. Keep in mind, you gotta do a shape and size description. So your shape is the drawings, size is the dimensions. Keep in mind, you go use some of this stuff over here, okay? Such as your general notes. Okay? The one item we haven't really talked about a lot is the general finish note, and let me kind of tell you where this is at. It's in chapter 10, and we covered it, but just kind of briefly. Let me give you that page. It's on page 529.
What page did you say?
529.
And I'll throw it up here on the thing. So we talked about finish notes when we want a surface finish, and we have a bunch of different types. This one's the general one right here. This is the one I want you to use. It's a V that sits whenever you see the edge of the surface you're talking about. Okay, you don't ever put it in the surface. You put it on the edge view of the surface. Okay, and then this one references to the general notes. Okay. These others all have notes attached to them. They're showing you the symbol, but they would have specific things right on the note itself. Okay. So I want you to use that Sharpie right here. And how you're going to use it is, in essence, really we only have a couple surfaces that are, so on the pin, so there it is. Well, let me switch my dim layer to a different color so you can see it. Let's go white. Okay. So all you do is put it whenever you see the edge view. Okay. So this thing needs to be machined off so it's nice and smooth, slides in and out without a lot of friction. So I put that one thing there. Now as soon as somebody sees that, they say, oh, I need to go to the general notes. So then they zip over to the general notes and they see one something like this, which is FIS. If you don't know what that means, look it up in the appendix. 263 microinches. And that's going to apply to every surface that has that little sharp V on it. Okay. Again, you've got that one in this view. In essence, we really only got this guy here and this. We can't finish inside of a hole, per se. So even though this hole mates with the pins, there's really no way to finish this hole without ruining it. So we're just going to leave it as the drill creates it. But this is a mating surface, that's a mating surface. You see it also here and here. So those are your mating surfaces. I elected to go with some sections, that's why you're seeing size of this negative cylinder and these over here. But you don't have to section it, it's up to you.
So why didn't you abbreviate micro and just abbreviate everything else?
Yeah, I don't know. Sorry, should we look
You'd
it
rub
up?
me off if I did that.
Should we look it up? Should we improve this drawing real quick?
Oh my gosh.
What is the abbreviation for microinches?
Micro
I don't
IM.
know.
I don't either. It's not one I memorized. I'm a dirt hog though, I'm a civil guy.
Micrometer. Micro. Alright, didn't have micro.
There you go.
Amper.
If in
Didn't have
doubt,
one.
if in doubt, spell it out.
Okay. He did that, just made me look it up.
All right, you do have some other things we asked for. We asked for 4 decimal places with the tolerance, RC4 fit for this guy, include them. They should be direct tolerancing. The other things I did put in this little chart that was also on the tolerancing thing, where I'm doing those due to specific figures. Specific, what's the word for that?
Specific.
Decimal, what is that?
Precision.
This one blank.
Decimal places. Oh,
Accurate.
Precision.
Significant figures, there it is, there it came. So you're using decimal places for the tolerancing on the rest. That's the way I went about it, you don't have to. You could come in here and then put your tolerancing on each one of these. So in essence, make sure your parts can't be confused with each other. You got plenty of room, you're on a B sheet, these are fairly small parts.
why did you put a legend instead of putting material down there?
Because that's the steel stuff, but I'm treating it with black oxide to reduce.
And that's different, I mean, different
Yeah.
than putting in the notes?
Black oxide is not a standard metal, it's been treated, the surface has been treated.
So how would we know to do that?
So the
You don't have to.
information under the legend refers to.
You can put material, black oxide steel,
Mhm.
that's all you need to do.
What about that other section, unless otherwise specified, tolerances are as follows? Why is that above the notes instead of integrated into the notes?
Because it's more of a chart. And in fact, most title blocks will have this in a chart where they've got a border and stuff for it. People that do that on every drawing. Again, look through that mechanical one, you'll see some examples of those, that mechanical flat file folder. Don't get too carried away with that. I just wanted to give you an idea. This is a 2-view drawing. I did include, by the way, you do have a tolerance on your angles if you use those. Here's a chamfer. You don't have to do it like this, which gives the X offset and the angle, but you do have the preference of it, and it's in your instructions. And so I included it down here in this, so anytime you see a degree, it's plus or minus 1 degree, which was specified in your instructions. And I think the rest of it's pretty, one other thing that's not clear on the drawing is the distance of this hole
Yes.
right here. Okay, and you had to go back to the original, and it's not in your text. This dimension, it says top on your drawing, it's 0.3. Okay, these holes are, this thing's not symmetrical. So what I'm talking about here is, on this drawing, for this piece, it doesn't give you the location of that hole.
Why would they make some more gravel if not being symmetrical? It's like more torque or something? Why would you do that?
I'm not exactly sure myself.
Okay.
Because the person before decided it.
Just to test you, just to make you.
So you're giving us that now, we don't have to.
You need it to draw.
Yeah.
Okay. Are there any real questions on this? Other than that, has anybody even started it? Nadia, do you have?
We just need to select it.
All right then. I just wanted to give you an idea of how to set that drawing up. Again, the big thing here, make sure the drawings can't be confused with each other. So give them a title, move them apart so that it's pretty obvious we're dealing with two different things. Any questions? All right, the rest of the day is yours. Please ask any questions as they come up. Thanks for your time.
Thank you.